Hello, welcome back to the channel. Today we're diving deep into one of the most in-demand skills, lead network security engineer focusing on Palo Alto firewalls. Whether you're preparing for an interview or troubleshooting in a production environment, this video covers critical questions, real-world scenarios, and practical tips, all broken down in a way that sticks. Let's jump right in. Question: what causes a packet to be dropped without appearing in traffic logs? Packets can be dropped at the ingress stage, during zone protection checks, or during TCP normalization, all before the security policy is even applied. This can happen if a packet is identified as malformed or violating a TCP state rule, for example. In these cases, the packet would be silently discarded without leaving any trace in the standard traffic logs. To troubleshoot these invisible drops, it's essential to leverage deeper diagnostics tools like debug dataplane, packet capture, and flow basics. These lower-level inspections can reveal exactly where in the processing pipeline the packet was dropped, even if it never made it to the main policy engine. Having a comprehensive understanding of Palo Alto's flow logic is critical for effectively managing and securing the firewall environment. Question: which is evaluated first, zone protection profile or DOS protection profile? In my experience, the zone protection profile is evaluated first before the DOS protection profile on Palo Alto firewalls. The zone protection checks are part of the ingress processing stage, happening even before the packet reaches the main security policy engine. This includes validating the source and destination zones, as well as performing checks for invalid or malformed packets. Only after the zone-based protection checks are completed will the packet then be evaluated against the DOS protection profile. This profile is designed to mitigate denial-of-service attacks by monitoring traffic patterns and applying rate-limiting or blocking rules if thresholds are exceeded. So the order of evaluation is zone protection profile, then DOS protection profile, and finally the security policy. Question: what's the difference between virtual routers and virtual systems? The key difference between virtual routers and virtual systems on Palo Alto firewalls is the scope and isolation of the network functions they provide. Virtual routers are independent routing and forwarding instances within a single physical firewall, allowing for separate routing tables, interfaces, and policies. This enables segmentation of the firewall's networking capabilities. In contrast, virtual systems, also known as VSYs, provide a higher level of segmentation and administrative isolation. A virtual system is a completely separate, self-contained instance of the firewall, with its own security policies, user accounts, logs, and other configurations. Virtual systems are akin to having multiple independent firewalls within a single physical appliance, enabling true multi-tenancy. Question: how do you troubleshoot phase 1/2 VPN issues or traffic not flowing despite tunnels being up? When troubleshooting phase 1 or phase 2 VPN issues or problems with VPN traffic not flowing despite the tunnels being up, I first check the phase 1 IX security association to ensure the configured parameters like encryption, authentication, and DH group are matching between the VPN peers. I also verify the pre-shared key or certificates are correct. Next, I look at the Phase 2 IPsec Security Association to confirm the selectors, encryption, and authentication settings are aligned between the endpoints. Mismatches here can prevent the tunnel from being established properly. I also closely examine the firewall policies to make sure there are rules permitting the VPN traffic to flow between the necessary zones and interfaces. Connectivity issues can arise if the policy configuration is incorrect. Additionally, I utilize packet captures and review the VPN-specific logs to identify any error messages or anomalies that could be causing the problem. This provides deeper visibility into where the handshaking or data transmission is breaking down. If needed, I may recreate the VPN configuration on a test system to isolate whether the issue is on the Palo Alto firewall side or the remote end. Question: what is split tunneling and how is it configured? Split tunneling is a VPN configuration where only specific traffic is routed through the VPN tunnel, while all other traffic is sent directly to the internet without going through the tunnel. This is configured on the Palo Alto firewall by creating two separate security policies. A VPN policy that permits traffic destined for the VPN remote networks to be routed through the IPsec tunnel. A local internet policy that allows all other traffic to bypass the VPN and go directly to the internet. The key is to have the VPN policy take precedence over the local internet policy, so that only the designated traffic is sent through the encrypted tunnel. This is typically done by placing the VPN policy at the top of the rule base, with a higher priority than the more general internet access policy. The benefits of split tunneling are reduced VPN bandwidth utilization, faster internet access for users, and simplified troubleshooting. However, it's important to carefully control which traffic is allowed to bypass the VPN, as it could introduce security risks if sensitive data is sent directly to the internet. Question: what are the key components of a Palo Alto security policy rule? The key components of a Palo Alto security policy rule are the security zone or interface where the traffic is originating from, the source IP address, address group, or user group, the security zone or interface that the traffic is destined for, the destination IP address, address group, or domain, the network application or application group to inspect and control, the protocol and port number of the traffic, the action the firewall should take on the traffic, such as allow, deny, or monitor, whether to log the traffic flow and at what level, any security profiles to apply like antivirus, URL filtering, etc., and the time windows when the rule should be active. Question: how does the firewall determine rule match order for security policies? The firewall evaluates rules top to bottom, with more specific rules taking precedence. It considers factors like source, destination, user, group, and application to ensure the most targeted rule is applied. Rule type and security profile comprehensiveness also impact the order. Question: what happens when traffic hits a default deny rule? The firewall blocks and logs the denied traffic, generating a security event. This provides visibility into blocked flows and helps identify policy gaps for optimization. The logs also aid troubleshooting. Question: explain the firewall's packet flow logic and how it affects logging. The Palo Alto firewall's packet flow logic is a key factor in determining what traffic is logged and how it's processed. Here's a high-level overview. The firewall first identifies the application associated with the traffic flow using its App ID technology. This application identification happens before any security policies are applied. Once the application is known, the firewall looks up the relevant security policy rules that apply to that traffic. The policy match process considers factors like source, destination, user, group, and service/port. If a policy rule is matched, the firewall applies any configured security profiles such as antivirus, URL filtering, or threat prevention. These profiles analyze the traffic in depth and can generate logging events. Based on the matched policy rule and security profile inspection, the firewall determines the appropriate action: allow, deny, or monitor the traffic. Now, in terms of how this affects logging, denied traffic that is explicitly denied by a policy rule will always be logged, as the deny action triggers a logging event. Allowed traffic that matches an allow policy rule may or may not be logged, depending on the logging settings configured in that rule. Monitored traffic that matches a monitor policy rule will always be logged, as the monitor action is specifically designed for logging purposes. Application level logging. The App ID identification and security profile inspection can also generate additional application level logs, providing deeper visibility into the traffic flows. Question: what are the key log types in Palo Alto? Traffic, threat, URL filtering, user ID, VPN, configuration, and system logs provide visibility into network activity, security events, user identity, and firewall health/operations. Question: what is application caching and how does it impact App ID? Caching stores previous application classifications, allowing the firewall to quickly identify repeat flows without reanalyzing packets. This improves performance and consistency, although the cache has a timeout period. Question: what's the significance of the control plane versus data plane in Palo Alto architecture? The distinction between the control plane and data plane is a fundamental aspect of the Palo Alto firewall's architecture and has significant implications for its performance, scalability, and security capabilities. The control plane in the Palo Alto firewall is responsible for the management and configuration functions, such as processing administrator commands and configuration changes. maintaining routing and policy tables, performing application identification, App ID, handling authentication and authorization. The data plane, on the other hand, is dedicated to the high-speed processing and forwarding of network traffic. It's where the actual packet inspection, security enforcement, and forwarding decisions take place. The significance of this separation is scalability. By offloading the computationally intensive data plane tasks to dedicated hardware, the control plane can focus on management functions without being a bottleneck. This allows the Palo Alto Firewall to scale to handle high-throughput network environments. Performance. The data plane's hardware-accelerated architecture enables it to process packets at line-rate speeds, ensuring minimal latency and impact on network throughput. This is crucial for real-time security enforcement and maintaining a seamless user experience. Security. The isolation of the control plane from the data plane enhances the overall security posture of the firewall. Any attacks or exploits targeting the control plane functions are contained and prevented from affecting the live traffic processing. Resilience. If the control plane were to experience issues or go offline, the data plane can continue to forward traffic based on the existing security policies and configurations. This ensures continued network availability and protection, even during management or software update operations. Question: walk through the steps for initial configuration of a Palo Alto firewall from scratch. Configuring a Palo Alto firewall from scratch involves several key steps. Here's how I would approach the initial setup. Physical installation. Properly mount the firewall hardware in the designated rack or location. Connect the necessary network interfaces, power supply, and console management ports. Initial management access. Use the console port to access the command line interface, CLI, and perform the initial configuration. Set the management IP address, netmask, and default gateway to establish connectivity. Licensing and registration. Register the firewall with Palo Alto Networks to activate the necessary licenses and subscriptions. This includes features like threat prevention, URL filtering, and wildfire. Network interface configuration. Define the security zones like untrust, trust, and DMZ, and associate the appropriate physical or VLAN interfaces. Configure IP addressing, DHCP servers, and any other interface-level settings. Virtual router configuration. Create a virtual router and configure static routes or dynamic routing protocols such as OSPF and BGP as needed. Ensure proper connectivity to the internal network and external/internet-facing interfaces. Security policy configuration. Define the initial security policy rules to allow necessary traffic flows and applications. Start with a permissive allow rule set, and then gradually tighten the policies based on the environment's specific requirements. User ID and application identification. Configure the user ID agent to integrate with the organization's directory services like Active Directory or LDAP. Enable App ID to ensure accurate application identification and control. VPN configuration if required. Set up any necessary site-to-site or remote access VPN tunnels. Define the IPsec parameters, authentication methods, and routing policies. Logging and reporting. Configure the log forwarding settings to send relevant logs to a CM or other monitoring solution. Customize the dashboard and reporting capabilities to provide visibility into network traffic and security events. Ongoing maintenance and updates. Schedule regular software updates and security content updates to ensure the firewall remains current and protected. Question: what interface types are available on a Palo Alto firewall and when would you use each? The firewall offers physical, VLAN, aggregate, sub-interfaces, and loopback interfaces. I would use physical for direct device connectivity, VLAN for network segmentation and security zones, aggregate for higher bandwidth and redundancy, sub-interfaces for granular logical segmentation, loopback for VPN termination and management. Question: what is tap mode and how is it different from VWire or Layer 3 mode? Tap mode is a passive, non-intrusive deployment where the firewall analyzes a traffic copy without being inline. vWire is a transparent Layer 2 inline deployment. Layer 3 mode integrates the firewall into the routing infrastructure for full security control. Tap is for monitoring, vWire for quick security insertion, and Layer 3 for comprehensive policy enforcement. Question: how does vWire work, and in what real-world scenario would it be preferred? In vWire mode, the Palo Alto firewall acts as a transparent Layer 2 bridge, forwarding traffic between network segments without IP changes. This enables seamless insertion into the network, making it ideal for upgrades or migrations where disruption must be minimized. Question: explain the use case for deploying Layer 3 interfaces in active-active HA mode. Active-active HA with Layer 3 interfaces is preferred for high-throughput mission-critical environments. It provides load sharing and failover redundancy while integrating the firewalls directly into the routing infrastructure for optimal traffic forwarding. Question: what are the key differences between active-passive and active-active HA deployments? Active-passive has a single active unit, while active-active shares the load across both. Active-active offers higher throughput and availability, but is more complex to configure compared to the failover-only active-passive model. Question: how does zone protection differ from DOS protection in Palo Alto firewalls? Zone protection limits the impact within network segments, while DOS protection safeguards the firewall itself from being overwhelmed. Together, they provide multi-layered defense against a range of threats. Question: what are the key differences between physical and virtual Palo Alto firewall platforms, and when would you choose one over the other? Physical firewalls excel at high throughput, latency-sensitive environments, while virtuals offer flexibility and scalability for dynamic, cloud-based networks. The choice depends on performance, security, and deployment requirements. Question: explain how to configure HA for a pair of physical firewalls in an active-active mode. Configuring an active-active high-availability HA setup for a pair of physical Palo Alto firewalls involves several key steps. Here's how I would approach it. Hardware preparation. I would ensure that the two physical Palo Alto firewall appliances are of the same model and software version. I would connect the HA ports of the two firewalls using a dedicated HA cable or a switch, creating a direct communication link between the devices. HA interface configuration. On each firewall, I would configure a dedicated HA interface and assign it an IP address from the same subnet. These HA interfaces are used for the exchange of configuration and session synchronization data between the two HA peers. HA cluster creation. I would then create the HA cluster by navigating to the device high availability page on one of the firewalls. I would specify the HA peer's IP address, and the firewalls would automatically form the HA cluster. HA mode selection. I would choose the active-active mode, which allows both firewalls to actively process and forward traffic simultaneously. HA mode selection. I would choose the active-active mode, which allows both firewalls to actively process and forward traffic simultaneously. Virtual router configuration. To enable load sharing, I would configure the virtual routers on both firewalls to use ECMP, equal cost multipath, routing. This would distribute the traffic load across the two active HA peers based on the configured routing policies. Failover considerations. I would review the failover criteria and thresholds to ensure the HA cluster would seamlessly transfer the active role from one firewall to the other in the event of a failure or resource exhaustion. Question: what is out-of-band access, and why is it important in enterprise environments? Out-of-band access refers to the ability to manage and troubleshoot network devices, like Palo Alto firewalls, through a separate, dedicated communication channel that is independent of the primary production network. In enterprise environments, out-of-band access is important for several key reasons. Out-of-band access allows me to manage the firewall through a separate, isolated network interface that is segregated from the primary data traffic. If the primary network experiences an outage or disruption, the out-of-band access channel can still provide a reliable way for me to connect to the firewall and perform critical management tasks. Many regulatory standards such as PCI DSS and HIPAA mandate the separation of management and production traffic for security and auditing purposes. Out-of-band access helps organizations meet these compliance requirements by providing a dedicated, auditable management channel. Question: how do you configure a management interface for out-of-band access, and why is it important in enterprise environments? Configuring a dedicated management interface for out-of-band access is an important best practice for Palo Alto firewalls, especially in enterprise environments. Here's how I would set it up. I would create a separate physical or VLAN interface on the firewall and designate it as the management interface. This interface would be assigned an IP address and subnet that is separate from the data plane interfaces. The management interface would be connected to a dedicated management network or VLAN, isolated from the production data traffic. This management network should have its own router, switches, and potentially a separate internet uplink for out-of-band access. Question: explain how to configure HA for a pair of physical firewalls. In an active-active mode, I would ensure that the two physical Palo Alto firewall appliances are of the same model and software version. I would connect the HA ports of the two firewalls using a dedicated HA cable or a switch, creating a direct communication link between the devices. On each firewall, I would configure a dedicated HA interface and assign it an IP address from the same subnet. These HA interfaces are used for the exchange of configuration and session synchronization data between the two HA peers. I would then create the HA cluster by navigating to the device high availability page on one of the firewalls. I would specify the HA peer's IP address, and the firewalls would automatically form the HA cluster. I would choose the active-active mode, which allows both firewalls to actively process and forward traffic simultaneously. To enable load sharing, I would configure the virtual routers on both firewalls to use ECMP, equal cost multipath routing. This would distribute the traffic load across the two active HA peers based on the configured routing policies. I would review the failover criteria and thresholds to ensure the HA cluster would seamlessly transfer the active role from one firewall to the other in the event of a failure or resource exhaustion. Question: how do you apply security patches and software updates to the PAN OS to maintain the firewall's security posture? I closely monitor the Palo Alto Network Support Portal and security advisories to stay informed about the latest software releases, bug fixes, and security vulnerabilities. Before applying any software updates or security patches to the production firewalls, I first test them in a non-production, isolated environment. I plan and communicate scheduled maintenance windows with the relevant stakeholders to ensure the firewall updates can be applied without disrupting business operations. During these maintenance windows, I would carefully coordinate the update process, including backing up the existing configuration, applying the updates, and validating the post-update functionality. For firewalls deployed in high availability, HA clusters, I would ensure the update process is performed in a manner that maintains network availability and minimizes downtime. This may involve updating the HA peers one at a time, or leveraging features like the version match requirement to coordinate the update process across the cluster. Question: how have you integrated user ID with Active Directory for user authentication? I have integrated Palo Alto's user ID with the organization's Active Directory environment for user authentication and visibility. Here's how I approached this integration. First, I ensured that the Active Directory configuration was properly set up and accessible from the Palo Alto firewall. This involved verifying connectivity, opening necessary ports, and configuring any intermediary firewalls. Next, I installed the Palo Alto User ID agent on a Windows server that had access to the Active Directory domain controllers. I then configured the agent with the required details, such as the Active Directory domain, user and group information, and the necessary authentication credentials. On the Palo Alto firewall, I navigated to the user ID settings and specified the IP address or FQDN of the user ID agent that I had deployed. I also configured the appropriate security zones and interfaces where the user ID functionality would be enabled. With the user ID integration in place, I began incorporating user and group information into the Palo Alto security policies. This allowed me to create rules based on user identity, enabling more granular access control and the application of security profiles. To monitor and gain visibility into user activity, I leveraged the user ID capabilities on the Palo Alto firewall. This included generating reports and dashboards that correlated network traffic with user identities, providing enhanced security insights. And that's your deep dive into Palo Alto firewall interview questions and real-world troubleshooting. Drop a comment if you want more lab walkthroughs or a follow-up on IPS profiles, threat signatures, and Global Protect deep dives. Don't forget to like, subscribe, and hit that bell. Your next role could depend on it. Until next time, stay secure, stay sharp.